Hello everyone, welcome back to our channel Problematical. Today we'll be discussing exercise 13.3 from class 11th Maths NCERT. The first question is, find the coordinates of the point which divides the line segment joining the points -2, 3, 5, 1, -4, 6 in the ratio 2:3 internally and then 2:3 externally. So first we will consider points, the mentioned points as the endpoints. So let A be -2, 3, 5 and B be 1, -4, 6. Coordinates of the point which divides it internally. P is my point which has internal division, x, y, z being its coordinates, and you are dividing the line in the ratio 2:3. First point, 2, second point, 3. A sequence or a proper order is always followed in such questions. So, P x, y, z bisection formula is equivalent to let's write the general formula first, since this is the first question. So if you have these points A and B, it has its coordinates x1, y1, z1, and B has its coordinates x2, y2, z2. And there's a point P which internally divides it in the ratio m:n. Then the coordinates of P, x, y, z can be written as P x, y, z is equals to m into x2 plus n into x1 upon m plus n This is first coordinate x, second m into y2 plus n into y1 upon m plus n, m into z2, m into z2 plus n into z1, n into z1 upon m plus n. So this is the general form. Now, instead of x1, y1, z1, we have -2, 3, 5, and instead of x2, y2, z2, we have 1, -4, 6. So here P, x, y, z will be equivalent to 2 into 1 plus 3 into -2 upon 2 plus 3, 2 into -4 plus 3 into 3. 2 into -4 plus 3 into 3 upon 2 plus 3, comma 2 into 6 plus 3 into 5 upon 2 plus 3. After calculation, let's calculate this. So P x, y, z will be equivalent to 2 into 1, 2, minus 3 into 2, 6, which is -4 upon 5. We have -4 upon 5, comma, -4 into 2, -8 plus 3 into 3, 9, which is 1 upon 5. 6 into 2 plus 6 into 2, 12 plus 3 into 5, 15, 27 upon 5. This is by internal division, first part. In the external division, we are using the same coordinates, but it is external division. So let that point be R. It's given that these are the 2 points A and B, and R externally divides it in the ratio 2:3. So the distance between R and A is 2 units, and distance between, or 2x, and distance between R and B is 3 units. So definitely your R lies closer to A. You can write something like, this is your R, this is your A, and this is your B. R divides AB in the ratio 2:3. This distance is 2, and this distance would be 3. 2:3. Let's say this is your point A, and okay, sorry, this distance is 2. Again, here the points will be -1, sorry, -2, 3, 5, and B is equals to -1, 1, 4, 6. This is your M, and this is your N. So according to the formula, here you'll subtract 2 into the other coordinate, x coordinate 1, minus 3 RB into other coordinate -2 upon 2 minus 3. X coordinate y coordinate 2 into -4 minus 3 into 3 upon 2 minus 3, 2 into 6 minus 3 into 5 upon 2 minus 3. 2 plus 6 upon 2 minus 3, which is 2 plus 6 is 8 upon 2 minus 3 is -1. So it is -8, comma 2 into -4 minus 8. -8 minus 9 is 17 upon -1. -17 upon -1, which would be plus 17. 12 minus 15 is -3 upon -1, which is plus 3. So your point P, coordinates of point P would be these: -4 by 5, 1 by 5, 27 by 5, and coordinates of R, which is the external division, will be -8, 17, and 3. Okay. Second question. Given that P, Q, and R are collinear, find the ratio in which Q divides PR. Now, P, Q, and R are collinear. Let's draw them. Find the ratio in which Q divides PR. So it's fine. Initially, you can consider any point as in any position. So Q can be considered as internal division, and then we can go from there. P and R. P is given as 3, 2, -4, and Q is given as 5, 4, -6. R is 9, 8, -10. Let Q divide PR in the ratio m:/n. We are assuming let Q divide PR in the ratio m:/n. Let m upon n is equals to k. Now, if Q is dividing PR in the ratio m:/n, this can be written as m upon n, which can further be written as m by n whole upon 1 or k upon 1. or k is to 1. So instead of mentioning the ratio m is to 1, we will mention it k is to 1. We'll get the value of k, and whatever fraction we get, that is m is to n, or m upon n. So instead of writing here m upon m is to n, we can write it k is to 1. Now solving this. Your Q point, according to section formula, bisection formula, your Q is equals to, or Q coordinates along with the coordinates 5, 4, minus 6 is equivalent to m into 9. Instead of using m and n, we are using k. So k into 9, 9k, internal division. So we'll calculate it with internal division, plus 1 into 3 upon k plus 1, comma, k into 8, 8k, minus plus 1 into 2, 2 upon k plus 1, k into minus 10, minus 10k, plus 1 into minus 4 upon k plus 1. So you can equate both sides. Your x coordinate will be equal, 5 will be equal to 9k plus 3 upon k plus 1. You can solve this taking k plus 1 on the left hand side. You have 5 into k plus 1 is equals to 9k plus 3. 5k plus 5 is equals to 9k plus 3. Therefore, 5 minus 3 will be equals to 9k minus 5k. 2 is equals to 4k, and k is equals to 1 by 2. K is equals to 1 by 2 means m upon n is equals to 1 by 2, which means this divides the ratio in the ratio m is to n. Your k value is equals to 1, or m value is equals to 1, and n is equals to 2. Q divides PR internally in the ratio one is to 2. If at all your k value is positive, if at all you encounter a k negative value, definitely you will have to then mention that Q is externally dividing PR in the respective given ratio. Next question. Find the ratio in which xy plane divides the line segment formed by joining the points -2, 4, 7 and 3, -5, 8. So what are you supposed to find out? There is a line segment joined by 2 points. The 2 points are -2, 4, 7 and 3, -5, 8. Let these points be A and B. You have to find the ratio. So m is to n is to be calculated, in which your YZ plane divides the line segment formed by joining these points. So here you have YZ plane, which is cutting this line at a particular point. So this could be the plane, but I'm representing the plane by a single line. So this is your YZ plane when you're looking from a side, and it's cutting this AB line segment in at one particular point. Let that point be C. Now in YZ plane, this point is lying in YZ plane. In YZ plane, we know that your x coordinate is 0. So C can be written as 0, Y, and Z. Now another way of looking at the same figure would be drawing the plane first. So let's do that. Let's try to get a better picture of it. So if this is your plane, okay, it looks more of a rectangle, so wait a second. If you have something like this is your YZ plane. And you have a line segment. That means there is a line which is, this is your point A, and this line is cutting this plane and then emerging from the other side. That means we are assuming that it is cutting through this plane at this particular point. The line is meeting the plane at only a single point. Let this be your plane, which is YZ plane. And this is your point A, -2, 4, 7. And this is your point B, 3, -5, and 8. And this is your point C, 0, Y, Z. Here, you are asked the ratio in which the plane cuts AB. So this is M is to N. M is the distance between AC. So M is this distance. And N would be this distance from C to B. This is M, this is N. You're supposed to calculate M is to N. The ratio in which your YZ plane cuts or divides AB. So how will you calculate? We'll just apply section formula over here. So bisection formula. Your C, 0, Y, Z will be equivalent to, applying the formula, M into 3, M into 3 is 3M, minus, internal division, so plus N into -2, which is -2N. This will be -2N plus minus upon M plus N, comma, second coordinate, -5M plus 4N upon M plus N, and 8M minus 7N upon M plus N. As you can see, you have 3 equations and you have 4 unknown variables, M, N, and Y and Z. So to reduce, to simplify this further, what we'll consider is, we'll consider M upon N as K. So you could have started here itself. You could have considered this as K is to 1, or here we are considering M upon N is equals to K. Since you're not supposed to find the value of M and just get to the ratio M is to N, you could get this ratio by equating this 0 with this. But once you get the ratio, it would be a rearrangement of the other 2 terms to get the values of Y and Z. So instead of going through that hassle, what we'll do is we'll substitute M upon N as K over here itself. So this equation can be rewritten as C0 Y Z can be written as, here if you divide by N on both sides, this is M upon N, N will get cancelled, M upon N plus 1. So it is 3K minus 2 upon K plus 1. Again, minus 5K, you can solve this and come up with the answer, plus 4 upon K plus 1. 8K minus 7 upon K plus 1. Now you have 3 equations, 3 unknown variables, K, equating 0 with this first value. So 0 it will be equal to 3K minus 2 upon K plus 1. 3K plus 1 into 0 would be 0. So 3K is equals to 2, or K is equals to 2 upon 3, which is equals to M upon N. This is your required ratio. Now, when I said 4 unknown variables, I meant the extension of this question. Also find the point. When you say this point, you're mentioning point of intersection maybe. This point of intersection would be the point at which your plane and line meets. This point is your C. So to get this particular part of the question, you have to find the value of y and z. For this, you'll have to equate your y with the second term on the right and your z with the third term on the right. Just recheck your z coordinates are 7. Why have we subtracted it? We should add it. Let's equate them. Your y will be equivalent to the second value minus 5k plus 4 upon k plus 1. And your z will be equivalent to 8k plus 7 upon k plus 1. Now your k value is found out to be 2 upon 3. If you substitute it over here and over here, you'll get the values of y and z. Y is equals to minus 5, 2 upon 3 plus 4 upon 2 by 3 plus 1. Your z is equals to 8, 2 upon 3 plus 7 upon 2 by 3 plus 1. This is equals to minus 10 plus 12 upon 3 whole upon 2 plus 3 upon 3. 3 will get cancelled. And here z will be equivalent to 16 plus 21 upon 3 upon 2 plus 3 upon 3. 3 again will get cancelled. You can take the denominator, flip it and multiply it with the numerator. That is also possible. This is 2 upon 5 y, and your z will be equivalent to 37 upon 5. Okay. Next question. Using section formula, show that the points A, B, and C are collinear. Now, to show that A, B, C are collinear, what we'll consider it as let P be any point which divides the line segment formed by any two of these points. So if we take a line segment, and here A, B, C, we are taking any 2 points, let's say A and B. Any 2 points can be considered. And let P be any point which divides it in the ratio m is to n. Or to simplify it, k is to 1, because m and n values are not given. So P point will be x, y, z. E is given as 2, minus 3, 4. And B is given as minus 1, 2, 1. So let's calculate by section formula. By section formula. Where P, x, comma, y, comma, z will be equivalent to minus k plus 2 upon k plus 1, 2k minus 3 upon k plus 1, z coordinate k plus 4 upon k plus 1. Now, your x coordinate comes around to be this, y coordinate comes around to be this, and z coordinate comes around to be this. If P were to coincide with C, if you say that these are equal, then we'll consider only one coordinate. Let x be equal to 0. Let x be equal to 0. So only one out of x, y, z coordinates we are equating it with C. If x is equals to 0, then calculate the value of k. So 0 will be equivalent to minus k plus 2 upon k plus 1 minus k plus 2 is equals to 0, which gives you k is equals to 2. Now, what happens if you substitute this k in the second and the third equations? The second equation would be y is equals to 2k minus 3 upon k plus 1, and z is equals to k plus 4 upon k plus 1. Putting k is equals to 2 in these equations. This is your second, and these two are considered to be your second and third equations. So this is your second equation and this is your third equation. Your y will be equal to 2 into 2 minus 3 upon 2 plus 1, and your z will be equal to 2 plus 4 upon 2 plus 1, which implies that y is equals to 4 minus 3, which is 1 upon 3, 2 plus 1 is 3, so 1 by 3. And your z is equals to 3 plus 2, 6, 4 plus 2, 6 upon 3, which is 2. So when you assumed your first value to be to be 0, you assumed your first k value to be 0, then you got a value of k and you substituted that value of k in the equation of y and z, and you got this point where your y is equals to 1 by 3, z is equals to 2, and earlier you assumed x is equals to 0. So we can see that point P coincides with point C. If you were to calculate ratio, your k is to 1 is the ratio, 2 is to 1. K is equals to 2 means 2 upon 1. Hence your m is to n would be 2 is to 1. But that is not asked. You are asked to prove that these points are collinear. Since your coordinate P coincides with C, you can replace P with C, 0, 1 by 3, and 2. And thereby, you can write the statement mentioning that point C, 0, 1 by 3, and 2 divides line segment AB with respect to coordinates in the ratio 2 is to 1 internally. Okay, next. Find the coordinates of the points which trisect the line segment joining the points P 4, 2, minus 6 and Q 10, minus 16, 6. So if you have a line segment PQ, you have to find the coordinates of the points which trisects this line segment. Trisects means dividing the line segment into 3 equal parts. To divide the line segment into 3 equal parts, we require 2 points. Let these points be A and B. Coordinates of point P and Q are mentioned: 4, 2, minus 6 and 10, minus 16, 6. When they trisect each other, we can say that this distance is to this distance is to this distance will be 1 is to 1 is to 1. 1 is to 1 is to 1. Let's assume these one at a time. First, we are considering these points, point P, A, and Q only. We'll forget that B exists. So we can see that point A divides PQ in the ratio of 1 is to 2. This divides in the ratio 1 is to 2. Using this and forgetting that B exists, we can solve for A. Let its coordinates be x, y, z. So your bisection formula can write point A, x, y, z will be equivalent to, applying section formula, 1 into 10, 10 plus 2 into 4 upon 1 plus 2 1 into minus 16 plus 2 into 2 upon 1 plus 2. And third point, 1 into 6 plus 2 into minus 6, which is minus 2 into 6 upon 1 plus 2. Therefore, this will be equivalent to 4 into 2, 8, 8 plus 10. Hold on. Yeah, 4 into 2, 8, 8 plus 10, 18, 18 upon 3, 6, comma, minus 16 plus 4 upon 3. So that would be 12, 4, minus 4. 6 into 2, 12, minus 6 over here, upon 3 in this one, 3 minus 2. So point A has coordinates 6, minus 4 and minus 2. Now, what you'll do is you'll forget that A exists and you'll only consider the point P. Now you'll consider P, B, and Q points. Again, let these coordinates be X, Y, and Z. So, your point B will divide this PQ in the ratio 2:1. This is 2:1. Again, bisection formula. The Bx, Y, Z will be equivalent to 2 into 10, 20 plus 4 into 1 upon 2 plus 1. Then you have minus 16 into 2 plus 2 into 1 upon 2 plus 1. 2 into 6 minus 1 into minus 6. So plus 1 into minus 6 upon 2 plus 1. This is equals to 24 upon 3, which is 8, minus 32 plus 2, 30 minus 30 upon 3 minus 10, 12 minus 6, 6, this one will be 2. So the coordinates of B are 8, minus 10, and 2. That concludes this exercise. Thank you.